In this video, we're going to be talking about first and second derivatives. So let's go ahead and define what these terms are. So let's say we have a function y equals f of x, right? Just a generic function. Now the first derivative of this function would be f prime of x. It's a new term, but it just means the same thing. It's the first derivative. And the reason we use the word first here, is because we do the derivative taking process. We take the derivative only once, right? That's why we call it the first derivative. We use the same methods as we have in our previous videos. We use our product rules, our quotient rules, but we do them only once. And that's why it's called the first derivative. And this is what we've been computing in all our past videos. Okay. The second derivative is commonly annotated as f double prime of x. Right? And there's a whole bunch of other notations, like, there's y double prime, there's d2y dx squared, and you'll probably see a whole bunch of others as well. But what they all mean is the second derivative. So now what this does is, as you might have guessed, is you take the derivative twice. Okay, that's basically what it is. So if you have some original function like f of x, then what you're doing is first you do your derivative taking process once, like we've done before, but then you take it again. That's basically all that it is. You take it twice. And you can extend this to higher order derivatives as well. So for example, if you wanted let's say we wanted the 20th derivative, right? Then that would just be f, we use these little parentheses here, it would be f20 of x. And what this would mean is basically we take derivative 20 times, right? So that's basically what this means. So you might wonder what all of this means, why this even matters, because it's basically just doing the same thing twice, or the same thing multiple times. Well, the thing is, it actually does have some applications in higher level mathematics, and the second derivative in particular gives us some very useful information in physics problems. So we'll be studying some of these applications. We're going to limit ourselves only to the second derivative for the purposes of these videos. But if you go into things like higher level integral calculus, or especially if you go into like other higher level mathematics, you will see that you will see like higher order derivatives used all the time, right? But yeah, that's basically what it is. Just one final comment I want to make is the second derivative can also be written as something else. You can also write it as first derivative. I'm just going to shorthand there, of the first derivative. Why can we do this? Because think about what's happening, right? So if you have a function f of x, right, and you do whatever derivative process, you end up with f prime of x, right? And then you do the derivative process again, and then you end up with f double prime of x. So if we just limited ourselves, if we just, let's say, drew a box around this portion over here, I can draw that better. If we drew a little box around just this portion over here, we just limited our field of vision to this, then all you see is that this function is the first derivative of that function, right? So therefore, you can think of the second derivative as being the first derivative of the first derivative of your function. And that's something that'll come in handy as well in your interpretation of what's going on here. So now let's talk about a physics problem. So let's say the function s of t represents your position from home. Let's pick an arbitrary function for s of t, some polynomial of t. So let's say s of t equals, let's say, 2t squared minus 7t plus 10. I'm just making up these numbers, they have no significance to me. So let's say that's our function for s of t. And keep in mind, s of t represents position from home as a function of time, a function of t. Okay. S prime of t, let's talk about what that be. If we just took the derivative of that function, s prime of t is equal to 4t minus 7, right? Now, what does this actually mean, though? What does this quantity mean? let's talk about that for a second. So remember, S of t represents your position from home. Now let's taking this back a step. What does a derivative actually do? A derivative calculates instantaneous rate of change, right? It's a rate of change. It calculates a rate of change at any instant x that you input, right? So therefore, S of S prime of t is an instantaneous rate of change of S of t. So therefore, we can think of S prime of t as being, and if we think of S of t as our position from home, we can think of S prime of t as being a rate of change of position from home, right? A rate of change of position at home. So at any instant time t, S prime of t tells you that your rate of change, the rate of change of your position from home. And a fancy word for this is basically velocity. The word we use for that is just basically velocity, and it's called v of t. Okay. Now this is where things get interesting. What does S double prime of t represent? And if we took the derivative, we know that S double prime of t is the same thing as v prime of t. Recall that because the second derivative is the first derivative of the first derivative, which is equal to, that would be 4, right? Now let's talk about what this really means in the physics context. So S double prime of t represents two things, right? It represents the second derivative of that, and it represents the first derivative of that, right? So I could write this as two different things. I could write this as a rate of change of a rate of change of a function, or I could write it as a rate of change, or as just a rate of change of a function. So there's two different ways I can interpret this. I can interpret this as a rate of change of a rate of change of position from home. Right? I can interpret this using two rates of change, a double rate of change, or I could simply realize that all of this is basically velocity and say that the net statement is that this would be a rate of change of velocity. Okay? And a rate of change of velocity is simply acceleration. And that is denoted by A of t. Okay? So I hope you see the kind of relations that we've derived here. So if S of t is your position from home and we have some arbitrary function for that, then the first derivative of S of t represents a rate of change of your position from home, right? It represents an instantaneous rate of change of your position from home, given some value of t. And that is velocity, and that's v of t. Now, S double prime of t represents, it could be thought of in two ways. It represents the rate of change of your rate of change of your position from home, because remember, you're doing this whole rate of change process twice with the second derivative, right? So you could think of it as a rate of change of a rate of change of your position from home, or that's actually case one. Let's title that case one. And this would be, you're thinking of it as double prime of t. In this case, you're thinking of it as v prime of t, or the instantaneous rate of change of velocity. So there's two different ways in which you can interpret this idea and derive what kind of information you get from there. If you found this video helpful, please do like, share, subscribe, leave a comment, and check out some other videos. See you next time!